one more bonus section to expand upon the ideas of the multiplication that we saw in the last section, where we saw multiplication of vectors in 3 ways, the last 2 being a bit strange, the dot product and the cross product. So what do those actually mean? Why do we have these mathematical ideas? And I took this from betterexplained.com, which has some really nice mathematical articles, since this is math, basically. The dot product, it turns out, appears all over physics. Some field, could be electric, gravitational, is pulling on some particle. We'd love to multiply, and we could if everything were lined up, but that's never the case. So we take the dot product to account for potential differences in direction. So some examples of this could be a solar panel, right? So the solar panel produces electrical energy that can power your house, but one of the key things with solar panels is you have to get them pointed at the light. If you have your solar panel, we can pretend this is a solar panel, and the light's over here, you're not going to get much energy. So what do you need? You need an overlap in direction times the strength of the sun rays, times the size of the panel, right? If you have a bigger solar panel, you'll collect more sunlight. The strength of the sunlight also matters. And then the direction of them. If the sunlight's coming in, you can have orange sun here. Sunlight's coming in and the panel is pointed directly at the sun, you're going to get the most energy out. And so the overlap in direction, how much these are pointed in the same direction, is given by this cosine of theta. So you might notice this equation here matches our dot product definition. One other example, perhaps more familiar to some of you, is in Mario Kart, right? There are these boost pads that give you a boost of speed, but depends on your initial speed going in. So the total boost you get is going to depend on your speed in the x direction times the amount of boost in that x direction, plus your speed in the y direction times the boost in that y direction. So the more you can line up with that boost pad, the more boost you get to win the race. What about the cross product? The cross product accumulates interactions between different dimensions. So this is a nice depiction of the dot and the cross product together. The dot takes all the like dimensions, all the x dimensions, the y and the z, all the similar parts, versus the cross product looks at all of the different dimensions and how they can interact. So all possible interactions are summed up by a combination of cross and dot product. So instead of thinking, when do I need the cross product? That's a really random name and a lot of scary math. Think instead, when do I need interactions between different dimensions? One example that you might not normally think of is area. Area is formed by vectors pointing in different directions. And you can have them pointing in more similar directions, but that'll be a smaller area. If you want a bigger area, you want them to be more orthogonal, more perpendicular, to get a larger area out. And technically the resultant of said area is always going to be perpendicular to that surface. So that's the result of the cross product. You didn't know it when you were calculating area, but you were actually calculating the cross product. And with the cross product, it is tricky to calculate. So I mentioned that I would highlight one other way that I like to think about in solving it. So let's take a look at that now. I will stop my share so this screen is a little bit bigger. All right. So if I have vector A crossed with vector B, then the way I will often like to think about this is the determinant method. And so to do this, I will write this as I hat times j hat times k hat, the 3 possible directions up there, with a sub x, a sub y, a sub z, and then bx, by, and bz. Right? This, by the way, is optional. You can use that equation that we showed previously in the slides, and it will work just fine. But if you're interested, stay tuned. So what we're going to do here in calculating this is we're going to look at each part So first I'm going to look at the I hat. When I look at the I hat, I actually cover up the x components of A and B. And I'm going to focus on taking the determinant or the cross product of these other ones here. So I hat is going to be multiplied by AY times BZ, and then subtracted by the other diagonal, the other cross that we would have here. So minus AZ BY. So that's our first term in calculating the cross product. Our second term is going to be the J hat. Now there are two different ways to do it. I'm going to do it the positive way, but it has an extra trick involved. So plus J hat. And for the J hat, you'll notice that when we cover up this middle column, now we have a gap that we can't quite cover. So what we're going to do is I'm going to add on these x components to the far right here. So A sub x and B sub x. And now, when we cover up our J hat, we can just do it with these ones over here. So AZ times BX minus AX BZ. All right, and one last piece is going to be our K hat. And so for this one, we will cover our K hat and we can just use our first ones here. So it would be AX times BY and then minus AY times BX. So all three terms here, sorry, I dropped off the bottom there, add up together to form the cross product. This is the equation that was in the slides. Now, in many cases, you won't need all three of these terms because in many cases, we'll be working with vectors that are only in the x and the y direction. If the vectors are only in the x and the y direction, then the z column disappears. If the z column disappears, that's going to affect the orange and the blue ones. So that means the I hat and the j hat directions are going to disappear. And if it is a two-dimensional vector problem, you're left with just this very last term. You're left with a vector in the z direction, k hat, with x and y components of A and B. So give it a shot. If you have more questions, please ask. I'm happy to help with vectors. The cross product is a beast. This is math, but it's good practice and it will help us out in the chapters to come.